Hi everybody, in this video series we're going to take a look at balancing oxidation-reduction reactions. So Lavoisier's law of conservation of mass states that mass of the products equals the mass of the reactants. And we know this because in a chemical reaction no atoms are lost or gained. We use coefficients to balance the total number of atoms of each type of reactants, and on the reactant side and on the product side. We've also worked with net ionic equations where we needed to balance both the number of atoms and the charge. In redox reactions, the charge is balanced by ensuring that the number of electrons lost equals the number of electrons gained. So you can see in this redox reaction here that zinc in its elemental form with an oxidation number of 0 goes to zinc with an oxidation state of +2. That means each zinc lost 2 electrons. Copper, on the other hand, goes from an oxidation state of +1 to its elemental form with an oxidation state of 0. So each copper gained 1 electron. So we have to put a coefficient of 2 here in front of the copper so that the number of electrons lost by zinc equals the number of electrons gained by copper. It is possible to split the oxidation and reduction portions of a redox reaction and write them as 2 separate half reactions. This is often necessary to balance complex redox reactions. So if we look at the reaction above, the oxidation portion of the reaction was when zinc in its elemental form was oxidized to zinc 2 ion. In order to do that, it must have released 2 electrons. The reduction portion of the reaction was when we had the copper 1 ion turning into copper in its elemental form. In order for that to happen, it would have to gain 1 electron. Now we can see zinc gave away 2 electrons and copper ion only accepted 1. So we need to double each of the reduction reaction components so that the number of electrons lost by zinc is the number gained by copper 1. And so that way we can now combine these 2 oxidation reduction into an overall reaction where we have zinc in its metallic form or elemental form reacting with 2 copper 1 ions to give zinc 2 ion and 2 copper in its elemental form.